If I sit here, will I block people's view of the screen? No? Because this one here is kind of very, very low. Yeah, I have no idea what's. I'll try to do it a little bit sideways. Okay, yes, we're recording, I hope. So the question is, how can you make it so that you put multiple copies of the JDK? The straightforward way of doing it works in Linux, where you have complete control where you want to put stuff. Because in Linux, there's you can get just a tar.gz file, and it's just a zip version of the development kit. You can put it anywhere at all where you want it. So I usually put mine on like oct. And so here you see I have a JDK 1.8.0. Well, as it happened, I put my 1.9 somewhere else. So I just have a directory where I have every JDK known to man, and then I just set the path to switch from one to the other. So right now my path contains JDK 1.8.0, but when I want to have 1.9.0 on the path, then I just change it and JDK 1.9.0/bin $path, and now when I say java.version, then it'll be 1.9. And so that way I can do whatever I want. Now on the Mac there is some system on how to you can definitely install multiple ones, and then there's some system to switch between them. I just don't remember right now how to do that. So that would be awfully nice if someone could try to do that and then put the answer on Piazza. That should be of general interest. What I do though, because most of the stuff that I do need JDK 8, but I like to run JShell. Mm-hmm. And so then you can put commands just for your own convenience into, and typically people put them in a directory called bin. So if you look at my bin directory, it has like a whole bunch of little things that I wrote over the time, like Wiley uploads files to my publisher and stuff. And so I have scripts in there, and one of the scripts I'll show you is bin JShell. And so that just runs wherever I have JShell. So when I type JShell, then it picks it up from there. So as a general strategy is make yourself a bin directory, add it to the path, and put whatever little utilities you want inside there. And it's all about control. So you want to learn how to do these little things.
What is cat? Does that just print the file or something?
Yeah, cat. I don't know why cat. It's always been cat since 1970.
Sorry, I have a Mac, but I have very, very little experience with Bash. So.
Right, and so that is actually one of the things that I will be relentlessly advocating, that everyone gets better at the shell. The shell is your friend, and like I say, when I log into a virtual machine that's somewhere, wherever they put virtual machines, I have no idea, right? Somewhere in a green field in Ohio. Then the only way that you can interact with it is that you log into it and you have a shell. So everyone needs shells. Talking of that, so I want to have a quick little Piazza poll here. So I'll just enter a few poll choices here. 2. So you go ahead and log into Piazza while I'm messing with this. Okay, so I would like you to answer the simple poll here in the next couple of minutes. So I just want to know, and for the homework, how this has been working out with me giving you those test cases. So you have 4 choices. If somehow they don't capture how you feel about it, then let me know in the comments. Oh, and I wanted to make it kind of anonymous. So.
What's that? A long time overall. And it didn't work out all months. Just yesterday. Let's see, from like. Probably like 3 hours yesterday. And probably 3 to 5 hours over the weekend.
All right, so I have 18 votes here right now. If I could please get the remaining 2 of you to vote as well. I think I've counted 20 in here, because I want to know who's actually here. So you can lie, but... All right, now I have 20 inputs. Great. So... So we have 14 people who know that they did everything right, and we have no one who says who didn't know what this was all about. There's 30 students in the class, 10 of whom aren't here, so I'll give you a little demo so that you see what these things look like on my site. So I'll show you where the repo is. I can make this a little bigger. Wait. So here, CS151 repos. So no, I just wanted to show. So here's all the students, and so I wrote a script. Here it is. That now grades all of the homework. You'll see it in action in just a minute. So. Yeah, I had to change the language to English so that you see the messages in English. So it goes through all of the directories in the repo, it makes a directory here, it copies the Java files, it copies the input files and the expected files, it then changes to that directory. Then it makes a file called scores.txt that starts out with the name of the student and the ID. Then it compiles the Java code and it puts the output of the compilation into scores.txt, including the error output. Then it goes through all of the input files, and for each of them it runs the mail system tester, redirects from the input file, redirects into a file that's generated by taking this variable I, changing input to output, and any errors that appear end up in scores.txt. Then I run diff, and it redirects the output of diff into scores.txt. That's all it does. So, at one point, it would be a really good idea if you could write a script like that. It took me this morning 8 minutes to do that. So, yeah, because I've done it so often that my fingers can do this on autopilot.
That's true.
So, so let me run this, and I have to remove the old run. So this was H2 grade.
cannot stack.
That means it can't, I don't know why it's stat, it's some system call. That means it can't find those files.
Oh,
Yeah, so if you see your name here flashing by, that means that you have a problem.
So the shortcut will give us the score directly?
It will give me what I need to grade the homework. It'll give all those the differences between the actual versus expected. I'll show you in just a second.
so a name popping up just means that their homework, their directory structured wrong, probably. Right?
Yes. And this other thing just happens to pop up because one of the commands CD minus for some reason echoes the current directory. I don't care about that because I only care about the results. I didn't try to make this pretty. So now in temp homework 2, I now have all of the various inputs and outputs and expected files and the scores thing. So let's look at all of them. Temp homework 2 asterisk scores.txt. So here we find a scores.txt that's in good shape. Right? So here all of the diffs are empty, which means that the actual output looks exactly like the expected output. Okay? Here you have one where it's not so. Well, this one was one of the one where it couldn't even find the Java files because either the student didn't submit it all or put them in the wrong directory. Here you have, again, one that's fine, one that's fine. This one, again, no Java files. This one here that did have Java files. They compiled correctly, but there were some minor differences, and it's easy enough to see what the differences are. So there are some spacing issues, right? So I would hope that we can get Craig here to make this minute change to his program and resubmit it. Okay? So this other thing here, that looks like there's some actual logic error in the program, so it's too late to fix that. But this little formatting thing, would make my life a lot easier if I could just get a fix for that. And really, there's no particular reason not to do that, right? I mean, how much does that cost you? Like 15 seconds? Yeah?
Would you consider running diff, and I think it's -W to ignore white space?
Yeah, but I'm not actually sure whether this will work with this white space. But we can try. It's a cheap thrill. Let's start a new Emacs. So you want diff dash W? That's,
Ignore all space. That was.
ignore all space. Okay, well. Yeah. So and notice again the beauty of just putting these things into a script. So now I've gotten a suggestion for improvement. I just threw away the old results and run it fresh. Oh, and by the way, there was a query, while we're waiting for this, there was a query as to what text editor you should use. You can use any text editor that you want. Of course, I'm not going to tell you what you use. Generally, there's the school of thought is that a text editor for a programmer is a lifelong investment, and so you want to choose something that's going to be with you for a good long time. So that probably means not TextPad or Notepad++, so one of these toy editors. And so what I put on this Piazza question, let me show that. If I can find it. Wait, what the heck was the question about text editors? Okay, I can find it, but I'll just show you the answer. So, in one of the 46B labs, it says, so in 46B we say, you can use any text editor you want, as long as it's Emacs, because we feel in 46B people are not mature enough to make their own choices. So, and so if you've never seen Emacs, then it's well worth your time to go through this part F here, where it shows a few things that you can do with Emacs, and this part G that shows a few more things that you can do with Emacs. You can completely ignore the rest of the lab. And then answer this last question, where it says, if you have a favorite editor, how do you insert special Unicode characters in it? How do you convert your text to Morse code? If you know how to do that in your favorite editor, stick with your favorite editor. So the advantage of a professional editor is that it can do all of those things, and you don't have to learn all of them on day one, but you will eventually want to know all of those things, and then you don't have to like first invest some time learning some crappy editor, and then later ditch that and finally take a serious one. So there are a number of reasonable choices, and you can't go wrong by choosing Emacs. The only thing is Emacs is ugly. Deal with it. Yeah, so if you'd rather have something pretty than something functional, then there are those choices too. But it really is worth the investment, and typically it takes people several years to get really good at one of those tools, but then they really are being very good at it, and it's a better deal than just doing something half-assed. All right, so let me get back to this one here, and we'll see if the white space things made a difference. What scores to text? Yeah, okay, well that was a good tip, thank you very much. So that definitely helped out Craig. So now we can see, most of them work fine. Here's a program that didn't even compile. This one here, okay, why didn't the white space help here? I don't have no.
Capital versus
Oh, the
lowercase.
capital versus lowercase. Yes, yes. All right, I'm going to go through all of those so that hopefully the video will work out today, that those of you who find yourself in this video in an unfortunate context, they have till tonight to submit a simple fix. All right. That's that, so that you know what it is that I'm doing. So what I'm going to do next is, with everyone who did pass this part, then I'm going to look at the code and see that the code is in decent shape. But I'm going to grade it, and at that point I'll be able to grade it pretty binary, right? Either it's good or it's not. And I don't have infinite time to do that, because I'm still behind with I just started looking at homework too. I will post the next homework, I want to say tonight, but it might end up being tomorrow morning, so that you have the weekend with it. So it's always a worry for me whether people start these homeworks in the very last minute. And I've said before, that's just really a terrible idea, because something will always go wrong. So I really would much prefer if you worked on them over the weekend and then have a couple of days to deal with any emergencies that might come up. All right, so let's get to the lecture. And so I'm again just be using the slides from the book. I have to update this front page here. So last time we looked at these three versions of the day class. And so now I want to talk a little bit about what this all meant. So remember, we had three implementations of what really is a fairly simple class, not super simple maybe, but also not super complex. And so even a fairly simple class can benefit from changing the implementation. And that happens all the time. Like I said, the string class in Java was recently re-implemented, and after years and years of use, someone had a better idea on how to deal with something. And so what's important is that when someone changes a class, that all the users out there can continue using the class just the way they've always used it. That's a fairly new thing. When I first started programming, there were no classes. All you had was functions, and so every library was just a whole bunch of functions. And it's very difficult to package a whole bunch of functions so that you can reorganize things the way you want. It's possible, but it's not easy. And so it was very common that someone would say, here's the new version of the library, now you all go and update your code so that you can work with that new version. This idea of that you should be able to publish an interface and not change it for 20 years, it was not, it was an ideal, but it was not commonly practiced. Whereas nowadays, I can take code that compiled under Java 1.0, and it still compiles under Java 1.9. It's actually kind of amazing. So for that to happen, you have to have that separation between the interface of the class and the implementation. So in the past, and probably more so when I wrote this book than now, people were quite used to using public instance variables. So it was not uncommon to see something like d.here. And you can still see a little vestige of that once in a while in the standard library. So let me show you an example. So here I have a point class. And so this is public class point. It was in Java 1.0, so it's about 20 years old. And at that time, people still wanted to have these public fields. Look, there's a public field X and a public field Y. Because they said, gosh, if I make that field private, and then I have to have an accessor, a getX and a getY, then wouldn't that slow down the computer? Because it's slower to call a method than it is to just get a variable. Why is it slower to call a method?
It has to do more. It has to actually call the method and then.
Right. So there's of course it has to make the call and then have a return statement. So that's a couple of statements. But there's something worse. That method calls 20 years ago, people were afraid of making method calls. They wanted to inline the code and put it right there. Because when I don't know if did you have a class in processor design yet? Like 147?
Yeah.
So the way that a processor works is it fetches instructions. And so it gets an instruction, it decodes it, it executes it, and so on. And that's how it worked when I was a kid. Nowadays, to wring some extra performance, there's multiple instructions get fetched in advance, and then the processor will actually try to parallelize and reorder some of them. So there's a whole pipeline of instructions. There's some part of the processor that will look at those instructions and see whether it can't execute some of them in parallel or reorder them or something. When you make a function call, that means that the pipeline has now become invalid, because now you're jumping to a different place in memory. And that is hugely expensive, throwing away that information. So people dislike function calls. And so in C++, you can actually say, I want to have this function inline so that you don't have to pay for the function call. In Java, on the other hand, nowadays, no one worries about this anymore because the Java virtual machine is super clever that it will look that no one else has overridden, like a getX method, and then it'll inline it for you. And if later a class gets loaded where getX was overridden, then, of course, now you have a situation where sometimes there might be different code happening. Then it'll undo the inlining. So a virtual machine can do that. At the time when people were used to C++, the C++ compiler couldn't. And the first Java virtual machine couldn't do any of that stuff either. So people were still bothered by method calls, and they wanted to have public data, just for efficiency. But public data is really bad because, when someone says d.year, and then of course they might somewhere say d.year plus plus. Now if I change the implementation so that the year field is dead and gone, then that's not really going to work, right? Am I going to tell everyone to hunt down their code for d.year plus plus and change it with something horrible like this? And so you should never ever use public fields, even though you do find the occasional example in a 20-year-old Java class. So I have never seen a modern class where anyone used public fields for anything, just so that you can have that evolution. Now, having said that, you might argue that for something like super simple, like a point or a rectangle, how bad can it get? And so, I don't want to oversell that point. But as a first approximation, just don't use public fields. It is a good idea to use the getters and setters. You might say it's really boring to write those getters and setters. So how can you deal with that problem? Yeah?
With the IntelliJ, you have a very quick.
That's exactly right. So what he's saying is that in IntelliJ, and also in Eclipse, and also in NetBeans, there's some keyboard shortcuts where you can quickly generate the getters and setters. The only problem with that approach is make sure not to over-generate them. You don't necessarily want to have a getter and setter for every field, because some of these fields are part of the private implementation. You don't want to expose them with getters and setters. But the ones that you need, by all means, control spaces in Eclipse. Go ahead and have those automatically generated. You still have to read them, so they still kind of clutter up the code, but that's okay. So we talked about accessors and mutators a little bit. So a mutator is simply an instance method that changes the state of the object. And so the rule of thumb is that mutators are bad. That's not always true. I mean, some classes it's hard to imagine them without a mutator. Like if you have an array list. An array list without a mutator would be weird, right? You could never change any of the elements in the array. Even though nowadays, so the ultimate reason why a mutator is bad, the most common reasons to say why mutators are bad is to say that it's really hard to then use them in concurrent programs. If you have a program where two threads access a shared variable, and then either of them could mutate them, and you don't have quite control over which one comes first, then it's very hard to know how your program behaves. We're going to see that more at the end of the semester. The other reason is that it just makes it harder to understand what a program does. So, in the way that I like to put it is, think of integers and strings. You've been programming with integers and strings for years now. Have you ever felt the desire to mutate an integer? Did you ever feel that you wanted to flip one of the bits in 13? Or were you actually pretty happy that 13 was always 13? When I was really young, younger than you are, I programmed in an ancient version of Fortran where you could actually accidentally mutate constants. And I made that mistake once, and what used to be 1,000 ended up being 500. And so every time I wrote 1,000, it actually changed them all to 500. It was not very good. So you really, it's easier to reason about programs when you don't have mutators or when you don't have too many. So immutable is good when you can get away with it. So with things like a calendar, like with a date or something, there's no reason not to make those immutable. So the Java 8 library does make them. Previously, it wasn't, and that was a flaw of the library. So another really useful rule is, so think of the day class. It has get year, get month, get day. And now let's say we wanted to make, and you're going to do that as a homework assignment. Let's say that for whatever reason you wanted to make a mutable version of day. So if you had a mutable version of day, then you could do the following. So you have a pen. So I'm looking to see if I have a pen for this computer.
Is a mutator just anything that actually changes the instance variables of a class?
Yes. I mean, it's exactly what you think. It modifies something in the class.
Setters are immutable.
So a setter is, actually that's a very good point that you bring up. Some people call a getter and setter, some people call a setter anything that mutates. And other people, such as me, call a setter something where the method name starts with SET. So I would call this a setter, and it's also a mutator. But if you think of, so for example, think of an array list, and now you have the remove method. Do you call remove a setter? Some people do. Some people do because it mutates, but I think that's weird.
Yeah.
So that's why I think the mutator is very clear and unambiguous, right? A mutator changes it. It sounds more sophisticated than a changer, but that's what it is, right? And so that's why I use the terminology accessor and mutator. Like, for example, with an array list, would you call .size a getter? Some people do, right? Because it doesn't mutate; it only gets some information. But I like accessor, mutator. Whereas a getter and setter is just something that sets, that really just have that get set prefix. So, so the reason I'm writing it on here is I'm taking a video of this. Hopefully it'll work this time. I managed to crash it somehow last time. And then everything that I have is captured there for anyone who wants to review it. So in the homework, you're going to be having, here we go. Except it's still a work in progress because it's not. I can't see what I'm writing. Oh, this is not going to work. Okay, because my screen is stretched. Okay, another thing for next time. That's fine. I'll just type it up. So in the homework, you're going to have, and I'll still call it a day. Let's come up with some day here. And so remember what we had when we said plus days? Then in the book, it makes a new day. In the homework, we're going to make it so that you simply say d.plusdays. That it mutates D, so that's the homework. And the book. So imagine that we right now have a day class that does this mutation thing. So and now the thought experiment that I wanted to have on the slide is, what if you then say, well, I have a day class, I have get year, and I have get month, and I have get day of month. And so if I have a getter, shouldn't I also have a setter? After all, this is now a mutable class. And the reason that it's bad to have setters for every getter is that setters can be harder to implement than getters. A getter just gets the field. But a setter is hard when there's relationships between the field. So look at this example here. I have January 1st. And now I'm going to call set month of 2.
31st.
Then I'm getting an invalid date, right? So that doesn't really work. And in this case, of course, you could avoid that by first setting the day of the month, and then all would be well, right? Then you would set it to 128 and then to 228. So by flipping those, you could avoid this error. But not always. So in this situation here, I'm in 228, and then here if I set the day first and then the month, then again it's wrong. So it would be very hard to have a correct interface for this. Weirdly enough, the Gregorian calendar class tries exactly that. The Gregorian calendar is that older version of a calendar in the Java library, and you can call set. The syntax is a little different. The API, I should say, is different. So you can actually change the month to 2 or to 3 or whatever. And then they have a crazy behavior where when you have January 31st, and then you set the month to 2, that they then say, well, you must have meant March 3rd. Or March 7th. I don't even know. I never understood that rollover behavior. It somehow adds 1 month, and by some definition of month, it's really crazy. And so that's probably a bad idea. So I will be formulating a homework that lets you explore that bad idea a little bit. You're just going to have to go with what I'm saying. And then you'll remember never to do that ever again. So here's another thing that's interesting about mutable objects. In the old Java library, the date class was mutable. So when you had a date, you could change the date that was stored in it. Now here I have an employee class that uses that old style date class. And that by itself, that's nothing wrong. At the time, that was what was given to us. So we have here a bunch of methods here that return the various fields, and I've omitted the other methods because I don't care about them. So now look at this code here. So I'm having an employee. I'm calling getHireDate, and I've shown you the implementation of the method, so you know exactly what it does. It returns this HireDate field. And now what happens is that the HireDate field inside the object and the date D are exactly a reference to the same thing. So here's D, here's Harry, and the HireDate and D are just pointers to the same object. That's how references work in Java. Right? You don't copy objects, you always copy references. So if now some fiendish programmer calls d.setTime, that's the mutator, then they can change your employee. So that is considered bad. There's an easy remedy, but maybe not one that they taught you in programmer's kindergarten. Namely, that when you have an accessor that returns a mutable object, you should always clone it. So you have a calling clone. And then that works. So, but do you religiously do that? I mean, it seems so much easier if you have immutable objects, then you don't have to remember that step. But that is super good advice. And every once in a while, there's some class in the standard library where they had forgotten that, where it actually leaks some internal state. And then some hackers take advantage of that and do something with it. There was something in number format. And I recently had to revise some slides for a presentation I'm giving. And there I pointed out that mistake. And then I was looking in the latest version of the source code. They fixed it, I think, in Java 1.7. So it was there for a long time, for 6 versions of Java, a bug just like that. So it's an easy bug to make. So another thing is, it's generally a good idea to use the final modifier. So when you have, not such a clear slide. Let me just look at one of your solutions, or one of my. I'll look at my code. That seems fair.
Quick question.
Yeah.
That's not a problem with native data types, is it?
You mean
Like
an int is always immutable?
right.
Yeah. And anyway, ints are the reason ints are immutable is that they're copied by value.
Yeah, they pass back and forth.
Well, let me actually look at the message queue. So when you look at the message queue over here, a message queue stores an array list of messages. And over here, what would not have been a bad idea is to put the keyword final here. And that's a very cheap indication of saying that no one's going to ever change that queue. Even though an array list is not an immutable class, at least now I know that no one's going to put a different one in here. It costs almost nothing. And so there are lots of people these days who say that final instance variables are a good default, and you should just make instance variables final unless you have a good reason not to. Yeah.
But this still can change the messages.
Totally. Yes. So it does not mean that the queue itself is immutable. All it means is that you can't put another array list in there.
So what is good to do that?
People say this is a generally good idea so that you think of instance variables. If your fingers start typing final for every instance variable, then you start thinking about those that aren't final. In other words, what would have been a good idea 20 years ago to make that the default. So 20 years ago, someone should have had the insight to say, final really is a better default, and maybe you would have had to say private mutable or something if you're non-final or var or something. So in modern languages like Scala, for example, one defines variables by saying val or var, and they beat it into you and say that you're a bad person if you use more than one var a day. So it's just like that to drive behavior. So I agree, for a simple class like this, you're not instantly going to get better quality out of it.
Actually, indeed, I don't know when should we use final.
What's that?
I mean,
So basically, they say you should always use final. Whenever you make an instance variable, make it final. And then when you find a reason why that didn't work, then the omission of the final tells you something about your design. So that's the thinking, and I think it's not a bad idea, and I should just start doing that as well for the code in the book. So here's another really good advice, and as a design rule. So let's say you have a class that has mutators, and I don't want to say all mutators are evil. There's plenty of times when mutation makes your life easy. There's a really good rule of thumb that says that when you have a mutator, something that changes the object that you work on, make it return void. That having something that both returns something and mutates is dubious. And I'll give you an example of that. Look at the scanner class that we use to read input. Look at the next method of the scanner. Is it a mutator or an accessor?
Accessor.
I'm glad I asked. So, one of the characteristics of an accessor is if you call it twice in a row without any intervening mutation, you've got to get the same answer back.
Okay.
Right? So if you have a day and you say, what's your month? And it says 11. What's your month? 11. What's your month? 11. Right? It's always going to be 11 until someone were to mutate that day. And if it's an immutable day, it's always going to be 11 from the creation of that object on till forever. But with a mutable object, accessors will still continue to give you the same answer unless there was some intervening mutation. Well, let's try it with the scanner. What's in dot next? Hello. What's in dot next? World. Right? So it can't be an accessor because it returns different pieces of information. Somewhere inside the scanner. We have no idea what a scanner looks like. Now, have you ever opened one up? Go ahead, take a scanner, take a scalpel, cut it open, and look inside. It's not pretty. Right, I have no idea what goes on in the scanner, but there's some data structure in there that must have some buffer and some pointer into the buffer, and that pointer gets advanced when you call next, so that you don't read the same thing twice. And then when it runs out of stuff, it must read new things and put them in the buffer or something. But it's a complex data structure with mutable state. Obviously with mutable state, because otherwise if you call next twice in a row, you get the same answer. So, and what's bad about it? As I know from sad experience, every once in a while I need to parse some text file, and I'll call next to get the next token out of the text file. And then I'm in some other corner of a complicated branch, and I'm saying, dang, I want to look at it again. And so that means that I previously must have stashed it away somewhere, like in just read token or some such thing. Whereas in C++, they separated this very nicely. In C++, I can say, I want to read something and then later can unread it. I can kind of go back. That's maybe a little artificial sometimes. In other libraries, you can peek at the next token. You say, I just want to see it. Show it to me. Give it to me. And then when you really want to consume it, then you can say consume. But you have this distinction between looking at it and consuming it. With these iterators and scanners, you can't do that. Next is the only game in town. And that's not very nice for the programmers. So this rule that says mutators should return void points out weaknesses in design. Now actually, it's a good idea to refine that rule a little bit. So here I call it, instead of calling it peek, I call it get current. But let's say the scanner had used my sage advice. They could have given us something that lets me see the current token, and then next would consume it. That way I could use it more conveniently. Or even better, they could make it so that get current gives me the current token without consuming it, and then this one here, this mutator, could do what it does today. It could just give me the current token and then advance. So a better rule is that it's fine for a mutator to return a value, provided there's also an accessor that gives you the same value. And so that's the kind of rule of good taste that one wants to use for writing mutators. So when you write a mutator, generally start out having it return void. But if you want to return an answer for convenience for the programmer, make sure that the programmer also has some other way of getting at the same answer without destruction. You don't want to force the programmer into mutation just to find some answer. Then God forbid they might have to undo the mutation. Okay, next thing about good quality, side effects. So a side effect of a method is any observable change. So if you think of a method such as string.length, has no side effect. You can call it once, you can call it 1,000 times, you always get the same result, it doesn't damage anything. Obviously, the scanner.next has a side effect somewhere inside the scanner because it changes behavior when you call it multiple times. Now every mutator changes the implicit parameter, and that's an unavoidable side effect. We may not love it, but that's what it is. But there are other side effects that you should definitely avoid. And here's an example of where it's done right. There's an add all method in collections, in the collection interface. So when you have like a list, you can call add all and add all of the elements from another list. Now let's suppose you do that. I have a list of friends, and I have another list of more friends, and now I call a.add all of b. What will b be afterwards?
Same.
Will it be the same? Or do you think all of the friends have been emptied out of b and put into a? What would you prefer? So it looks like everyone wants it to be the same. And I totally agree with that, right? You would find it surprising if it somehow sucked out the contents of B and put it into A. It wouldn't be like illegal or anything, right? They could just publish it and say that's the behavior. But it would really drive you crazy. And so that is the rule for avoiding side effects on parameters. So unless there's a really super good reason to the contrary, you want to make it so that parameters are never mutated when you pass them to a method. And the Java library does super well with that. One time I was trying to find a method that violates that, and I had to look long and hard, and I found some obscure method somewhere. But in general, the assumption is very clear that if you give something, then it doesn't change. I mean, the only difference might be if you give like an iterator or a stream to something. Those do have to get consumed because what else can I do with it? But that's generally considered bad design.
Professor.
Yeah.
So iterator is actually also a mutator, right?
That is a very good question. So what she's asking is, let me get some scratch thing here.
Because you cannot get that.
So your question is if I have like an array list. So I get some array list of friends. And now I'll get an iterator of string by saying friends.list iterator. And so that's where the terminology kind of breaks out, because by itself, is it a mutator? The array list still looks the same, but it's a more insidious thing. It is something that later allows you to carry out mutation. I'll be talking about that in a minute. So I understand the question, but I don't think that's settled terminology whether you would call that a mutator. And technically, you would say no, because all of the instance variables of friends are still the same afterwards.
Yeah.
But you can now start mutating friends.
Right.
Yeah. All right. I hear. So another side effect would be if somewhere you had a static object, maybe a static counter, and when calling a method, you increment that counter. And that way, if you call the method 5 times, it would now be different than calling it 1 time. And it's hidden away in some counter, and that's considered a bad thing. So you should try not to do that. Let's say I have an example of that here. Yeah, I don't want to show this one in the interest of time. This was the obscure method that I found that I don't deal with. But this is the one that I want to talk about. Consider this implementation here of some message queue. If new messages is full, system out, print on, sorry, no space. That's a side effect. I have a static object, system.out, and I'm mutating it. Is print on a mutator? So system.out is an object, right? An object of type print string. Now I call print on it. Well, is it a mutator or isn't it? Does system.out look different after I've called print on it?
Sure.
Well, remember, so you use the rule of thumb. If I do it 5 times, is it different than if I do it once? If you have a string and you call string.length, 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 and string.length, that string is no different than it was before. I told you 5 times what the length was, but it didn't change it anyway. If I call system.out print on 5 times, that's different than calling it once. Right? Something happened somewhere in the world that's now different. And what is system.out really? What does it look like? What's inside system.out?
String.
There must be some strings and maybe some buffer, and it's attached to some something in the operating system, but it has stuff inside. And the call to print on will take some characters and push them into some buffer so that eventually they get flushed out. So that buffer is being mutated. So this thing here is a mutation. It's a mutation of a global object, of a static object. That's a side effect, and you don't want to do it. And so the reason here why you don't want to do this particular thing is now that message queue is no longer usable in an environment that doesn't have system.out. Is there any environment that doesn't have system.out? Have you ever been anywhere in the world where there wasn't system.out?
Sure.
Like where?
That is the system.
Yeah, like your toaster oven does not have system.out, right? Your Java powered toaster oven, there is no system.out. Right? Your phone doesn't have system.out. Your car doesn't have system.out. There are actually very few things that have system.out. Think about it. Does your web server have system.out? You're making a web application and you're printing system.out. How are you going to check for it? You're not on, you're sitting on your browser. You don't see what goes on the web server when the web server says system.out. Maybe you're redirecting all standard output to a log. And I speak with passion here because nowadays, so it used to be, that was actually the case. On the web server you could say system.out println and it would show up in some log. Nowadays, how do you get to the log? Your virtual machine is dead before you get to the log. Because when you have a bunch of virtual machines that are load balanced, when they're not busy enough, the load balancer will kill them. And so you may be looking for that log message, and you don't even have a log anymore. So simply to try to think that system.out has any relevance outside your desktop, that's just not so. And so you don't want to hardwire those dependencies in there. All right. So the next law, and that'll, yeah, go ahead.
So we don't print system.out because this will give the load to the server? Or?
No, it's just that no one's going to be there. Like if a tree falls in the middle of the forest, and no one is there to hear it. Did it ever fall? And the same thing, if you do system.out println on a server, and that server is then taken away by the load balancer, was it ever printed? It's just a futile thing, and you just don't even want to get into it. So that's why in homework 2, I said make it so that all of the I/O is in a single class, in the console class. That way you can just yank out that one class. So that's a useful just rule of thumb, and say localize those things as much as you can. All right. So the next thing in terms of good design is this oddly called law of Demeter. So think of, and I'll talk about your iterator in a minute. So think of the mailbox that we had in that mail system. And there was a call that said find mailbox. So we're asking the mail system to find a mailbox. The mail system manages a bunch of mailboxes. And now the mail system is willing to hand a mailbox to someone. That's potentially dangerous, right? Because whoever gets that mailbox can then do anything that they want with it. And they can mess with the messages. It's like when I ask you, give me your liver for a few minutes. Right? You might be apprehensive about that. But I'll give it right now, or promise not to mess with it. So basically the law of Demeter says you don't want to give your liver. That would be a better name for it. So you don't generally want to give out things that let someone else mutate your internal state. It's bad design because it makes it harder to reason about your programs. And so that's really the case here with the iterator. That an array list, really ought to be in charge of its destiny, and giving someone else an iterator, is iffy. What are they going to do with that? You could think if it was a read-only iterator, that would be fine. If that iterator could only be used to read the state of the thing, but a immutable iterator, is kind of questionable. Now, if you think about it, when you have an array list, when is the last time you called the iterator method on an array list? Like I've been using array lists for 20 years, and I can tell you with confidence that I've done that exactly never.
But there are cases for like hash map. So iterator. Would
you give someone an iterator to get hash map? I don't know. I mean, you can do it, but it's legal Java, right? But is there a use case for it? Why would you want to give someone an iterator? You give them the hash map. So the iterators have very restricted utility. Just about the only reason that I can see why you would ever need an iterator is for linked lists. Because with a linked list, you need some way of specifying a position. And even then, you could think of an API where you say, okay, I'm willing to give out the iterator, but then it would be just like a glorified integer, and I'd have to give it back to the linked list. And anyway, when's the last time you used a linked list? Been programming for 20 years, and I can tell you that exactly never, except for student programs. Right? And linked lists are not exactly the most common use data. I mean, really, in an application program, when did you use a linked list? For what? Right? It's an implementation detail in a queue, maybe. And even then, why wouldn't you just use an array queue? So it's pretty unusual to actually use a linked list. Why did they torture you with linked lists in 46B? That's other than that they hate you, which is true too. But no, I mean the reason is that A, it's a good training wheel for trees, and trees are important because you can get an order of efficiency improvement out of trees that you could not get with other data structures. So you have to learn about trees. And the other one is it does give you like a training wheels approach to reason about efficiency a little bit. You can think about insertion in the middle of an array versus insertion in the middle of a list. So it gives you something fairly tangible. But yeah, in terms of application programming, really, I go ahead and grab the entire Java library source code for linked list, and I'd be stunned if you see it anywhere except in the linked list class itself. Yeah.
So I just wanted to clarify something. So the example you gave before, for example, on this most recent one, we have a mail system that has, well, when we changed it had users. And I know I implemented the console with the console taking a user from the mail system.
Yeah,
So
that one I think is fair because the users are immutable.
Because otherwise, what do you have? You have a name, and then you have to constantly have the mail system go get it every time. Right?
That's totally fine. So if you have something where it says, let me get the slide back up, sorry. Where you have find user, no sweat. Because the user is an immutable object. Oh no, your user had a mailbox.
Yeah.
Yeah, that's a little iffy, right? So at that point, it makes it pretty hard to do a design that fulfills this law. And so when I say it's the law of De Beer, that doesn't mean it's like the law of Pythagoras. It's not a universal law. It's just a good idea.
Right.
And it actually is kind of a good idea because if you think a little bit, let's say you design a web application. In that case, you would have the mail system on the server, and you would have your user interface in JavaScript in the client or in Java on a phone. And so would you really ship the entire mailbox down? You would probably have an API that says, tell me how many messages are in that mailbox. Give me the ith message. And the message is immutable. So it is actually a pretty good law that says generally try to structure your API so that one doesn't give out mutable parts.
So mutable parts like a reference.
No, it doesn't have to be a reference. Like when imagine a system where the user class is immutable, where you separate the user from the mailbox. Not like in homework 2, probably all of you. Is there anyone who did not put the mailbox inside the user? You could have a different system, right? You could have users and mailboxes separate, and then use some kind of table to match them up. So let's say you did that. So you have a list of users and you have a parallel list of mailboxes. Would perfectly work. In that case, just giving out the user would be fine. The user would just be some immutable object with username and password. Nothing wrong with that. With the mailbox, if you give out a copy of the mailbox, that might be okay, like a read-only copy that couldn't be mutated. That would still be within the law. So you can give me a copy of your liver, and you're not going to worry too much.
So the clone method is basically a deep copy, or
What's that? Yes. So cloning the mailbox, that would work just fine. So the law basically says, don't give a mutable part of yourself to someone. And so, like I said, you can always solve this by giving the big system more methods. And like all these things, it's a rule of thumb. Good design means you have to weigh these different things. Are you making your thing too complicated? That's no good. But it is not a bad thing to at least think about. So I want to end this here by a few simple quality considerations. So when you make a user interface, that your customers are the programmers who use, not a user interface, a class interface. Your customers are the programmers who use that class. And so I have these 5 criteria that all neatly start with C that I want to present. The most important one is that we want a class to be cohesive. So a class should describe a single abstraction. So like if you have, for example, the instant class, that was a good example. An instant is a point in time. It's no more and no less. And an instant is not munged up with calendars and leap years. And so that's considered a pure design. You have a single concept. And you can usually see that by looking at the methods of the class. If the methods of the class are all related to that single concept, then that's great. If the methods are all over, and there's more than one concept lurking in there, that can be bad. Like here I'm having a mailbox, and the first 3 are great. Add message, get current message, remove current message. That means a mailbox is a container for messages. Single concept. And now I have this one, process command, and that sticks out like a sore thumb. What's that got to do with messages? Right? That command processing responsibility, that can really be handled by another class, as it is in both the program in the book and in your homework solution. Right? There you have the connection or console or whatever that deals with command processing, not the mailbox. And so the principle of cohesion says make it so that a class is really focused on one set of things, and that it doesn't do too much.
Is that process command is a good one?
No, it's bad. It's bad. This is what makes it non-cohesive, because now this mailbox here deals both with message collections and with command interpretation.
Yeah.
Those are 2 completely different responsibilities that have nothing to do with each other. And so you should develop an eye for that and say, these 3 all belong together. This one, not at all. It's a different thing. And then you want to break up the class into 2. This happens all the time. And so I've seen some of you, when we did that exercise with the whiteboarding, like some of you came up with a statistics class. And that was a good idea, right? That says we have all of the statistics stuff. We didn't want to put that together with the questions and so on. And so there you saw the need to say, let's separate those responsibilities. So that was a good instinct of whoever did that. Another thing that you want in a class is completeness. So the date class is potentially a bad example. The old date class, say I have a start date and an end date, and I want to find out what's the difference between these. And there was no way in the date class to actually figure out how many minutes or how many seconds were between these 2. And so it doesn't seem to be very complete in that regard. And that's really mostly a criterion for, well, I shouldn't say that. This will happen like when you're in a project and one of you gets tasked with doing a class that is responsible for whatever, managing messages or questions or something. And then another team member says, gosh, I need to get at that information. Why didn't the clown who designed this class give me this essential information? So that means that when you design a class, you kind of have to think of your customers and see what should you give them. In the Java API, almost all of the classes are very, very good when it comes to completeness, because they have been designed for millions of users who are very noisy when a class doesn't have what it takes. But every once in a while, I do find one where I say, gosh, why didn't they just add that method to this class? It would make my life so much easier. And then if enough people complain, then in the next version of Java, actually it does tend to appear. The next thing is convenience. So a good interface should, of course, make all tasks possible, and it should also make common tasks simple. There are examples all over for inconvenient interfaces. So before the scanner class existed, if you wanted to read a bunch of lines from a file, you couldn't just get the file and get a bunch of lines. Instead, you had to make a buffered reader that wrapped an input stream reader that either took system.in or a file and came. And so it was completely unnecessary. What do I care about buffering and input stream readering? I just want to get the lines of the file. So nowadays, if you want to get the lines of a file, you do it like that. So nowadays in Java 7, they added a convenient class files with all sorts of convenience methods, and one of them gives me the lines of a file. So that's how it should be. That's convenient. Even the scanner is not that convenient. So convenience means that's the stuff that you need to do all the time. It should be really easy. And the Java library is pretty good there, and every once in a while you find something where you say, gosh, this should not be as hard as it is.
So that files.lines just gives you an array of strings?
It gives you a stream of strings, actually. You don't yet know what a stream is. You'll learn it eventually. There's another method called readlines that gives you a list of lines. Okay, I'll give you something that is inconvenient, that really should be easy. Let's say you have a short file, and you just want to read it into a single string. You have a text file, a short text file. And all you want is a string that has everything off that file. Just suck it in. How do you do that? You have to get a scanner. You have to read them in a line at a time. You have to add them all to one string. You have to make sure that you separate them with new lines because they get lost in the reading process. Or you can use an input stream and you can read them 1,024 characters at a time and then worry about the last block, and then you turn them into a string. I mean, all of that sounds like ridiculous why you have to do that. In Python, you can just read it in with one command. So there ought to be a thing that says, just give me the darn thing as a string. I know it's short. So, clarity. So, this is a reminder for how linked lists work. With linked lists, you need, as we just talked, an iterator that iterates over a linked list. And so let's assume that you remember how an iterator works. Now, the thing that I want to talk about is removing things from a linked list. So let's say I have a linked list like this. How do I remove the y? So the interface works is that I have to get an iterator. Then I call next. And what would then happen if I call remove? Then it removes the one to the left. So I have to jump over this one. And then I'll call remove. And then it removes the one to the left. Now let's say that I happen to be at the end here. And I call previous on the iterator. What will happen when I call remove?
Take out Z because it goes off to the next.
Will it remove the one to the left, like the backspace key on your keyboard? Or will it remove the one that you've just passed by?
Just pass by.
It removes the one you just passed by. Just imagine the backspace key on your keyboard would work like that. If you happened to use the cursor key in one direction, backspace would work differently than if you use the cursor keys in the other direction. Right, so that would be really confusing, and yet that interface is there. So not a good idea. And you can tell it's not a good idea by a very simple test. You look at the API documentation. Tells me it's in the class. Okay, I have no idea. So but I'm just going to tell you. So in the API documentation, it says, removes from the list the last element that was returned by next or previous. This call can only be made once per call to next or previous. It can be made only if add has not been called after the last call to next or previous. Everything clear? So if you have to write documentation like that, then that tells you that maybe your design was not the best. So I'm going to stop here. You can read the rest yourself. So the point that I want to get in here is that design is not an accident. It is something that you do have to think about when you design an API. You really want to think through what the decisions are that you're making and what they mean for your users. All right, so there's no class on Tuesday or Thursday. There's no point in showing up here unless you like to see the hallway. I will send out some information of what activities I want you to do on those days over the weekend. All right, thank you.